Hello everyone. Today inshallah we will continue our yesterday lectures. I will continue solving on chain rule, Taylor formula, and of course the homogeneity problems. And we will have a couple of problems here today that connects everything all together, as I told you. Let's start with this problem. It's really a very nice problem, a very simple one. He's giving you, of course, in each of these problems, before you think about the solution, you will have to ask yourself, this is which case of the cases that we did go through in the previous lecture. So it's really essential to review the last lecture, try to solve as much as possible, then you will find this lecture is really very easy. He gave you an f of x and y, which is x squared y plus sine of x, and you have x as a function in t, y as a function in t, and he wants you to use the chain rule in order to compute the derivative of the function, okay, h of t, and he is giving you the form of this function. If you remark, for the function h of t, I want you to compute the derivatives of h of t, which is given by 2 of t squared, f of x and t, y and t, on the given form. So I would start to think about this case. You have given f, which consists mainly of two functions. Each one of them is a function by itself in another variable. So simply all I have to do, and the first step, is to understand this scheme, which represents that f is a function in x and y, while x is a function in t and y is a function in t. So if I want to differentiate, I will have to respect this rule. So if I were in your shoe, the first thing to think about is to do the following. Partial h partial t will equal to, as we tried yesterday, I will differentiate h with respect to its variables. As you can see that h contains f, and in f you have x and y. So I will start differentiating with respect to t. This is a clear function in t, which is gonna be a 4 of t. This is out of our game. Then I will go to the composite function f of x and t, y and t. So I will do partial f partial x times partial x partial t plus partial f partial y times partial y partial t. This is how it is done. I will differentiate first f with respect to its variables, which means I'll differentiate f with respect to x plus with respect to y. Then I will put the junction that will connect the derivative with respect to x to the derivative with respect to t. This is why I'm doing partial x partial t. But remark, I can write the actual or the better for this case in specific, not to write partial x partial t, is to write dx by dt, and dy by dt. Why? Because x is a function only in t. So I'm using the total derivative symbol. Okay? So it's really very simple. The next step is we will start substituting. So as I told you, the first step is to differentiate the first part, which is going to be direct. It's going to lead you to 4t. Then I will differentiate f with respect to x, which will come from this part. Then differentiation of f with respect to y, also from this part. Then I will differentiate x with respect to t times the derivative of y with respect to t. So simply, the next step is to differentiate f with respect to x. Let's start differentiating. So this part is going to be 2x times y. This is going to be a cosine of x. This is for the first part. Then, remark Miss Judy, I will differentiate dx by dt. So it will come from here, 3t squared. I will repeat. I will differentiate partial f partial y. So it will leave you with just only x squared. So, sine of x, the derivative will be 0. Times dy by dt, which is going to be simply 1 over t. Then the final step, I will start, okay, substituting instead of x and y by their values, which are t cubed and ln of t, and that's the final form of your answer. The derivative of h with respect to t, it's going to be in this form. This is a much better problem, well constructed. This is really very important idea. See how it's all going to work together. First of all, he gave you, consider h which running from R2 into R. So this function h represents from R2 into R, which means it's a function in several variables. Then, such that the gradient of h, and please be careful about this, the gradient of h is 6 and 2. At 6 and 2, I'm sorry, is equal to -1 and 2. And the value of the function h at 6 and 2 is equal to 1. So all of this are knowledge or data you will have given, you will have to keep them with you. Also, a function for f, it's running from R2 into R, and that's the formulation of f, which is y times the function of h, which contains two components, xy plus x squared and 2y squared, which runs from R2 into an R. Okay, I want you to determine partial f, partial x, and the partial f, partial y first. So that's the first case. Then we will compute the gradient vector of f, not of h. You understand what I'm saying? Of f at the points 2 and 1. Then determine the second derivative of f with respect to x squared. This problem connects a lot of things all together. So I will start with step by step. First of all, okay, we need to find the derivative. This is the derivative of the function with respect to x and with respect to y. So I will need to identify it. We did go through this previously. I can consider this value by itself as u and that value by itself as v. And then differentiating partial f, partial x will lead to. If I'm differentiating f with respect to x, means I will differentiate h because it's a function in h, but just multiplied in y. Since we are differentiating with respect to x, Judy, then y is a constant, so y will come down. Then I will differentiate this part. As you can see, this is a composite function. So how to differentiate? I will open a bracket, I will differentiate h first with respect to u, then differentiate u with respect to x, and differentiate h with respect to v times the derivative of v with respect to x. That's the derivative for with respect to x. So I have my function, it consists of this function and that one too, or of this coordinate and that coordinate. In this coordinate you can see x and y. In here, the general case is to have x and y, but here I just have y. So let's start differentiating. I will do this with you step by step, and we will see the rest on the slides. So if I start differentiating, I will start to differentiate partial u, partial h, partial u. It will remain as it is. So partial h, partial u times, I will differentiate u with respect to x, which is gonna leave you with y plus a 2 of an x, and that's it. This value will be multiplied by y. Kareem, do you know why? Because simply partial v, partial x is gonna equal to 0. If you look to v, v just only 2y squared. So differentiating 2y squared with respect to x will leave you with 0. 0 times whatever, it's gonna be 0. So it says 0 times partial h, partial v, which is gonna be cancelled. And so the derivative of f with respect to x is simply y squared plus 2xy, and all of it is multiplied by partial h, partial u, but don't forget that h by itself is xy plus x squared and 2y squared. You said, why did I wrote all of this? It's enough to write partial h, partial u, and that's it. Why I wrote those two guys? or the details of the function of h in the partial derivative, because he may ask you is about these values, and these values are function or they will equal to, so the 6, for example, it's equal to xy plus x squared. Do you understand what I'm saying? So we need to keep focus on this, okay? That's the derivative with respect to x. Judy, can you do the derivative with respect to y? I need to differentiate this function with respect to y. With respect to y, it will be a little bit complicated. Why? Because you have two main functions multiplied in y. So the first derivative will be differentiating y, which is equal to 1 times h, then plus. You will have y, then you will have to differentiate h by the same rule. The only difference is that this is going to be partial u, partial y, partial v, partial y, as you would see. So once more, that's the first, this is my function, this is u and v. The next step is to try to differentiate with respect to x. Y is a constant. I will get partial h, partial u times partial u, partial x. That's the first component. The second component, we didn't write it. This is because partial v on partial x is equal to 0, so the only part. Then we start substituting, as you can see, this is the result. Done. Now I will have to differentiate with respect to 2y. The first thing that you will remark in differentiating with respect to y, I will differentiate y equal to 1 times h, and then I will differentiate h times y. See, Karim, that's the second one. Then I will start differentiating this guy with respect to y. It's exactly the same like this one, but instead of x, you will have y derivatives. Are you with me? Now I will have to substitute. The substitution is very, very simple. Partial h, partial u will remain, but you said I will differentiate u with respect to y. Okay, so once more, I will differentiate with respect to y, it's going to be x. Then times partial v, partial y. I will differentiate with respect to y, which is going to be 4 of y. And of course, I will try to simplify as much as possible. That's the simplest of all. Don't panic from having this long statement, but it's because I've wrote h is a function in x, y plus y squared, blah, 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 blah. And I'm writing this not for this problem, or not for this part, but for the coming part, that he will start to ask you about the gradient vector. Okay, the next part. All of this are done already. I have the first derivative with respect to x, and the first derivative with respect to y. I've already wrote them for you. That's h, and that's the first derivative with respect to x that we already evaluated, and that's the first derivative with respect to y that's already done within the first requirement. The second, he wants you to compute the gradient. Please wake up. He wants you to compute the gradient vector of f at 2 and 1. Okay? So focus. This means you will, that the next value, or the first value and the second value. That means the first value from the gradient vector is the derivative of f with respect to x at the point 2 and 1. And Karim, exactly right. The second component, which is the derivative of f with respect to y at 2 and 1. Okay, are you with me? Okay, very good. So the values of 2 and 1, remark, if I'm getting partial f, partial x at 2 and 1, I will start substituting in this value, or in this partial derivative. Remark that each x is 2 and each y is 1. So it's gonna be simply, if you start substituting, you will find the following, that this is 1 plus 2 times 2, so the total of all of this is 5. That's the first component. Then I will need to find the derivative of h with respect to u at 2 and 1. And in this case, I would deeply advise that you get back to the given. If you get back to the given, he already announced this in the given parts. Look, this is partial h at 6 and 2. which is negative 1 and 2. Are you with me? Okay. Let's test what is 6. 6 is the value of xy plus x squared at 1 and 2. So if I start to substitute at 1 and 2, this is gonna be 1 times 2, which is 2, plus 2 squared, which is 4. The sum of them is 6. And this one too, Judy, please focus. It's gonna be 2. So this value is at 6 and 2. The given, the gradient vector, it means partial h, partial x at 6 and 2. And also partial h, partial y at the indicated point. In this case, I can substitute. So instead of having partial h, partial u, I can use the value which is negative 1. I'm sorry, this is the value. This is the value of partial h, partial u, the function by itself, and this is partial h, partial v, which is going to equal to negative 1 and 2. Because both u and v already contain the substitution of x squared plus 2xy, or the given function. Are you with me? Kareem, okay? Then this is going to be negative 1, multiplying them together, you will have negative 5. In a similar manner. And this is confusing, okay? This is why I'm telling you, you have to focus on this. Getting partial f, partial y, it's exactly the same. This is the main function. Remark, Judy, the value of partial f, partial y at 2 and 1, it will equal to the value of h at, replace x and y by 2 and 1, which will leave you at 6 and 2. I will also look at this, so this value is 1. So I will replace this guy by positive 1, and so on. So everything, they like this form so much, okay? Because mainly, this way, I've tested your understanding for the differences in the partial derivatives, and also in the substitution and in the composite function. Okay? So once more, I will start substitute. Partial h, partial u, already given by negative 1. Partial h, partial v at 6 and 2, which is 2. All I have to do is just to make a substitution. So now I know that the gradient at f21 is equal to negative 3 and 7. Imagine if this is a multiple choice problem. You have multiple choice and you will have to choose the correct answer. So it's really a very good question. The last, you want you to evaluate partial 2f, partial x squared. Remark that mainly partial h, partial u by itself, it's a composite function. Because the first derivative by itself is a function in u and v. While u is a function in x and y. And v also is a function in y only in my case. So, in order to get the second derivative, I will have to, the second derivative with respect to x, so I will differentiate this equation once more with respect to x. So I've taken my equation and I will start differentiating. Of course, the first derivative will differentiate this part times the first derivative. So it's gonna be a 2 over y, just only 2y, this is gonna be 0. 2y times the first derivative in h, partial u, as you can see. Then plus, the first, Mr. Kareem will remain the same. The first is the same. And then I will start differentiating once more. Partial h, partial u. As general case, I will differentiate partial h, partial u. I will differentiate again with respect to u. So it's gonna be partial 2h, partial u squared times partial u, partial x, plus partial 2h, partial u, partial v, times partial v, partial x, plus partial v, partial x is equal to 0. This is why you can see only the first part of them. Do you understand what I'm saying? Okay, I will write it for you once more. Okay, so simply forget this. If I want to rewrite it, this is the first part, this is the second part. This is part number 1, part number 2. The first of them, differentiating part number 1 times part number 2. Already happened. Then I will replace. So the first of them, which is y squared plus 2 of an xy by itself, then I will start differentiating the first derivative. I will differentiate the first derivative, this part, with respect to x. Once more, differentiate with me. So, a derivative for the first derivative will be the second derivative. Are you with me, Mr. Yusuf? Partial u squared, which means I will differentiate the first derivative once more with respect to u. You added partial u, so I will multiply by partial u, partial of x. Then plus, it should be like this. Then plus. I still differentiating with respect to u. So I will take the partial to h, partial u, partial v, then partial v, partial of x. In my problem, in our problem, Miss Shruti, okay, in our problem, you have partial v, partial x is equal to 0. This is why this part completely will be removed. And you will have just only the first of them, which is exactly as you can see. Now, all I have to do is to just substitute with the derivative of partial u, partial x, leaving partial 2u, partial y squared as it is. So simply, this is going to be the case. Differentiating u once more with respect to x, which will leave you with y plus 2x as you can see. And that's the final form, of course, after writing xy plus x squared plus 2y squared. This is really a very important problem. As you can see, it was 5 marks. It was a question. If we, I'm thinking, if I'm going to put the exam, if it was not sent from there, and if I want to put from there, from over there in Lisbon, and if I want to put this exam, it seems a very nice problem to be towards 5 marks. First, I've tested your understanding about the partial derivative and the chain rule. Second, you know very good the gradient vector. What does it stand for and how to get the values of each one of them. You are very good in substitution, so you already understand the difference between x, y, u, and v, and how to connect them together. Higher order derivative, it's perfect. Okay? Also, the coming examples are the same, or the coming problems are the same. Let's look to another problem. In this problem, also, it's a test for more than one issue. Let's look together. He wants you to, first of all, you have G, and G is mapping from R2 into R. So it's mapping elements from R2 into R. And it's a C infinity, which means that you can differentiate as much as you like. It's a homogeneous of degree 3. That's a new knowledge. A homogeneous of degree 3 related to the homogeneity. Okay, so it's a very good given. And such that the gradient of G at 2 and 0, so you will have to understand what's 2 and what's 0 in G, will equal 2, negative 1, and 2. So those are the x and y's, and those are the values of the derivative at the indicated points. You have to understand this. Okay, very good. What I mean is 2 is the value of y, and 0 is the value of x, and so on. And also remark this trick. He gave you, Kareem, f of x and y. Please look at it. F of x and y. It's equal to 1 over g of y squared and the x squared. Which means you are not going to take x squared. No. He replaced, okay, the places of the values of x and y. This is y squared and then x squared. Remark, these points are really very important. Usually when you are solving in the exam, it may go on you. Okay? So please be careful about this. Okay, go on. Show that f is also homogeneous. So he gave me that G is homogeneous of degree 3. He wants you to see if H is homogeneous and indicate the degree of homogeneity, which is a little bit simple. Then he wants you to compute the value of f at 0 and 1. Okay, the value of f at 0 and 1. Let's do it together. This is really a very nice problem. So the first step, This is f of xy, which equal to 1 divided by y squared plus x squared. Look how I'm going to study the homogeneity of this function. In order to see if f is homogeneous or not, all I have to do is to replace every x by x and t and every y by y and t. So f of xt yt is equal to 1 over g, which is of y squared, so it's going to be y squared t squared, and x squared, which means x squared and t squared. Okay, but there is another issue, that g is homogeneous and of order 3, which means any common value from the argument of j to go out, it will go with a power of 3. So simply, this is gonna be t to the power of 2, all of them power 3, times g of y squared t squared and x squared t squared. And from this point, you will have that the homogeneity degree is t to the power of negative 6. Because simply, it's going to equal to 1 t to the power of negative 6. I will take the t value times 1 over g of y squared plus x squared, which means t to the power of negative 6 times the f of x and y. So it's a homogeneous function with degree to the power of negative 6, as you can see. So once more, this is tx and ty, Kareem. All I have to do is to make the substitution. So replacing y by ty, replacing x by tx, then taking t squared as a common. Takes t squared as a common out of g according to the given homogeneity. Anything from inside to go outside, it will go with power 3. So it's going to be simply t to the power of 6. Then I can put this 6 to be t to the power of negative 6. 1 over g by itself, it is f. So I've regained the main shape of the function, which is f of x and y, times t to the power of negative 6, which means it's a homogeneous function of degree negative 6. That's for the first part. To go for the second part, this is f at 0 and 1. So instead of dealing with f at 0 and 1, as I told you, focus. This is x and y. This is y squared, x squared. So if I'm talking about f at 0 and 1, it means the first component, it's going to be y to the power of 2. So it's a 1. And x squared, which is a 0. You have 1 over g at 1 and 0. Okay, but I don't have any given in this problem for the value of g at 1 and 0. But instead, I can use Euler theory. If you remember, I have at the gradient vector, which is at 2 and 0 equal to negative 1 and 2. And that g is differentiable and homogeneous of degree 3. So we can use Euler equality or Euler equation. Euler equation states the following. Okay, I already added Euler equation for you in order to remember what's Euler or what was said in the previous lecture. This is Euler equation, which states for any function homogeneous times the homogeneity, so this is g, this is alpha is equal to 3. It will equal to the derivative of the function with respect to the first variable, the derivative of the function with respect to its variables, times the coordinates x1 and x2. If I want to apply this, it's going to be really very simple. So it's going to be, first of all, see, the degree of homogeneity is equal to 3 times g, which is given by x and y. And this is what equal to partial g, partial x, partial g, partial x, okay, times x plus partial g, partial y times y. This is what's Euler about. I will expand using advantage of the knowledge of the value of the gradient vector, okay, and this will help me in Euler identifying the values of Euler of the given Euler formula. So it's a partial G, partial U, plus times U, plus V times partial G, partial V, which is 2 and 0. That will equal to 3 times G of U and V, where U is given by y squared, and the V is given by x squared. Okay? So the second step, of course, this is U, which is 2, and that's V, which is 0. The next step is to start substituting. Partial G, partial U, partial G, partial U for the first components is -1. And the partial G, partial Y for the second component is equal to 2. So all I have to substitute is to start substituting. So, what's Mr. Karim? This is 2 times -1, then plus, this is 0 times 2. So 2 times -1, that's what's gonna remain. This is gonna be 0, and that's 3 G of 2 and 0. Remark, that's the G of 2 and 0, which is equal to -2 over 3. Am I right? Okay, but I need to find the value at 0 and 1. The value at 0 and 1 is equal to 1 for the function g1 and 0. Am I right? But this is 2 and 0. So what to do? Once more, I will remember the homogeneity property, which states that if I took a common factor from the denominator, a common factor from the argument, it would go outside but with power 3. So بص كده كريم, G will equal to 2 times 1 and 0 is equal to -2 over 3. So simply, if this 2 go outside, it will go to 2 to the power of 3. Am I right? This is the homogeneity. And that's the point that you need to know. Okay, from this point, I can know now that G at 1 and 0, or indicate that G at 1 and 0, it's a -2 divided by 12. I'm sorry, -1 divided by 12. Because I will take 2 out with the 8, it will remain 4, then divide by 4, it's going to be -1 over 12. Okay? That's the value of G1 and 0. Now I can find simply the value of F just by substituting. So, F at 0 and 1 is equal to 1 over G at 1 and 0. Now I know G at 1 and 0 is equal to -1 over -1 over 12, which means it's equal to -12, as you will see. So the last step is just willing that F01 is equal to -12. See how it is manipulated. Although it's very, very simple, but he didn't get to the point exactly. But in this problem, we used the homogeneity. We had the advantage of using homogeneity in 2 times. In discovering if the function is homogeneous or not, and determine the homogeneity degree, and also in applying Euler's theory, and start identifying how to reach our point. Also, as a very good problem also for training, okay? Let's see the coming problem. I've tried to solve as much as possible, and you still have a lot of problems to go through them. Please try to solve them again. This problem, it is in the second midterm exam of 23-24. Let's go through it. Consider the function g, which is from R2 into R. It's obvious from R2 into R. Okay, knowing that, once more, the gradient of g is at 0, 0 is equal to 0 and 0. And that the Hessian matrix, do you remember what's the Hessian matrix, Mr. Karim? Why? It is partial 2f partial x squared. Okay, partial, this is the Hessian of g, so it's a partial 2g partial x squared. So that's the Hessian matrix, of course you remember, of course. That's the Hessian matrix, which is partial 2g partial x squared, partial 2g partial x partial y, partial 2g partial y partial x, partial to g partial y square. It is given to you, -2, +2, a and b. Okay, determine a and b, that's the first question, which is inshallah simple. Then write the second order Taylor's formula. So in this part, it's connecting the chain theory, okay, or the knowledge of how to connect the first derivatives, okay, with the Hessian matrix, second derivatives, and the Taylor expansion in multivariable functions. So Miss Judy, I will start step by step, taking advantage from this matrix. We know that the Hessian matrix is a symmetric matrix. What's a symmetric matrix? The symmetric matrices, they have the same elements around the principal diagonal, which means that A is equal to 2. That's the first. صح? And then it will also mean that partial 2g partial y squared is the value of b. So I will need to get the Hessian or the second derivative of g at the 0. So all I have to do, Mr. Karim, is to take the g function and differentiate it how many times? 2 times. So here we go. That's the g. These are the givens. Then I will, I know that the function a is equal to 2. Then in order to get the second derivative with respect to y, it means I will start differentiating, okay, as I told you, g, how many times? 2 times, with respect to y. The first derivative with respect to y will give you the first part, the first, the 2 minus x will remain the same, but I will differentiate e to the power of xy, which means, with respect to y, which means x times e to the power of xy, as you can see. So it's a x, 2 minus x squared, times e to the power of x and y. That's the first derivative. Differentiate once more. When you differentiate once more, the only part, Judy, that will be differentiated is the power of the exponential function, leaving you with another x. So that's the second derivative. So instead of having just only x, it's going to be x squared times 2 minus x squared to e to the power of x and y. Now start substituting at the origin, because this is the Hessian matrix at the origin. So all I have to do is to replace x and x, y zeros, and will leave you with a value of 0. So your Hessian at the time being can be given by the following